Hello everyone, it's April 5th. Old problem, must be. Largest divisible subset. A set of distinct positive integers. Return the largest subset answer such that every pair of elements in the subset satisfies a distinct positive integer set. Return the largest subset answer such that every pair in it satisfies they are divisible. If they're multiple, return any one of them. So 1, 2, 3 will be 1, 2, 1, 3. That will be 2, 4, 8. 1, 2, 4, 8. Divisible. I smell union fine. Yeah. I think this is union fine. You. Oh, 2 times 10 to the 9th. I think it's still good. Oh, okay, it's map. Not really. 2 times 10 to the 9th, I think it's still good. And we just, if they're divisible, we just put them in the same group, right? And eventually we will go through everybody, find the parents, right? And put them in the same. Okay. I think we need to do union find. Oh. I forgot how to set it up again. But it's okay. Okay, that is, yeah. I think that should be fine. This is our constructor. And then we'll do union, no, fine. Ah. We're gonna use indices, right? Yeah, we're gonna use the indices. Mm-hmm. All right, I think this is the DSU. Okay. Three 868. Okay, I say if nums I mod nums j equals 0 or nums j mod nums I to 0 dsu dot union ij. Okay. Once this is done, I need to know the size, right? So I need a map. Groups. Groups P dot push back nums I. Okay, and then I'm gonna find the maximum. How do I iterate through map? Auto const key value. Larger than max size. Oh, we also need to have I don't need this. I just need a max group. Okay, let's take a look. Oh, yeah, maybe syntax error, but so I'm still not quite sure how this one is done. That's interesting. Oh, every single pair. Oh, shoot. Oh, this is not right. Oh, yeah. So, everybody will be in order. Yeah, this is not right. Ah, that's the trick. So in find 2, you can group them together, but then you need to make sure that it is also divisible. Huh. Okay. Have to rethink. Let's sort it first. Alright, let's sort it first. So we sorted. Okay, so let's say we sort this. And what we can do is for each number, because it's sorted, we'll go the biggest one. Right, so I'm here. I can check every single one to see which one is good, which one is divisible. Right? And if that's divisible, then maybe another one is divisible. Right? Hold on, let me think. Let me think again. Basically for each one I need to find, so for each one, like A0, I can, if A0 I can say I can have this, all multiples of A0, right? And then A1 can also have multiple, and A2 can also have multiple, right? So this is just like A0 I can have a bunch of children, A1 I can have a bunch children, A2 I can have a bunch children, and now I just go from A0, I go from every single one, to go from every single one, to go from every single one, right? And then that's it, that's from A0. right? Going through whole thing. And that user I can go through every single one. And then if it's visited, it's just done, right? And then we go from A1. We check if A1 has visited. If A1 is visited, I don't have to visit again because it has already been done. But it has not, and I go through the same thing again. And I just, from A1, I have all the children, right? And then I just, and DFS the whole thing, and then, okay, so essentially what you're saying is that we're going to redo the whole thing, which is fine. Actually, I'm going to keep the DSU. Let's not keep it here because that was the wrong direction. All right, so let's do it. Let's do it again. Now this time, what we're gonna do is, first things first, we're gonna sort it. I think sorting it is very important. Oh. Okay, so I sort it, and then we're gonna have a graph. Actually, no, I think I can do. Sort nums and then produce a graph where the children are the multiples of the node. Child values, right? The child value is multiples of the node value. Then we traverse the map from the lowest node value and find a path with the find the longest path. Okay, so that's that, and then we're gonna do a graph. So I think size, that's the useful. So we're gonna have a vector of vector graph n. I don't think I need another one. All right, and then we'll say n. If nums j mod nums I is equal to 0, then we do graph I dot pushback j. Okay, so prepare this, and we're going to have std vector int scene. All right, and we need a BFS. So we need a path. How do I handle that? Global variable. I don't like the idea of global variable. Just pass it. We can push pop and then clear. So it'll be void DFS. Oh. Okay. Right, so our index, we shall say if now every time we come, we'll have the true end is it doesn't have anything, right? So its graph is like 0. That's when you hit the end, right? That's when you hit the end, because if you have something, then you can definitely go. So the hit end is if graph index is empty, okay, then the current path, we need a path as well. Current path is, so we say if path.size is larger than rest.size and rest.clear, and for path rest pushback p, right? And then that's it. Else I think each time I should add it first. Right. We add it first, check, and then pop back at the end. Else, then for child of graph index, perfectly normal. If not seen child, alright, I think seen shall be a boolean. Right, if a not seen, do that. DFS child graph nums seen path res. Okay. Then we have seen, and now say seen 0 true. Actually, no. Because I want to go through every single one of them. Yeah, you know what? Let's also add this. If scene index, just return. Right. Otherwise, C index equal to true. Double. So we do it here, and then we do it here. So now for here, I can just say for I graph nums scene path. Now I return res. Does this one work? Bloody did not. I wonder why. All right, I have some structural issues. Yeah, it should be false, right? So if it's seen, if it's true, we return, but it's not true. So I set it to true. I path or push this, which is fine. Sprinkle this around. Let's get a sense of what happens. Like, does we come in here? Graph index. Zero, right? So 0 comes in. It's the child. One and two, that's correct. Right? So we do 1. Now 1 comes in. Oh, it already. Ugh, I see. Yeah, I cannot do it twice. If not seen, I. Right, if it's not seen, we go in. Okay, this I feel should be right. Yep. No. Oh, I wonder why. Oh, I see why. Because I didn't keep track. Yeah. It has to be a little bit DP here as well, right? Yeah. Holy crap. How do we do this? I'm gonna change. DPI is the longest path starting from. No, I'm sorry. So DP this is the last one, right? It's the biggest. Actually, we can do it. Yeah, hold a second. I think we can do it in the. I think we should say DPI. If it's empty, then we do this. Graph nums. I don't need this. I do need a path. Do we even need a path? Do we even need a path? Like for each thing, I basically produce the longest path starting from here, which means I don't think I need it. I don't think I need this. I think I need this. Alright. So I always say DP index can be pushed back nums index. Right. Then we find its children. Then we go for all of its children, and we say if dp child is empty. Right, if it's empty, then we will go through it. Right, if its child is empty, we've never done before, so we go through it. And we're going to find the longest child, right? Find the longest child. Yeah, so we get a max child size. And then for here, we're gonna say for okay, now we just need to go through the whole thing and find the maximum. Right? I don't need max size. Okay, let's do this again. I hope we'll have better luck. What? What the hell is this? 1, 2, 1. What in the world? I think I know why. Yep, I know why. Set to -1. This I think shall do. Okay. Yeah, this one does. Yeah, not the best performance, but I'll take it. 30 and 10%. Oh, we have to copy and paste the solution. Well, it's definitely n squared because this takes on squared. And then every node visit once. Yeah, but we also have this pushback, so I don't know. I don't know if it's the best. I feel like there should be a better way to represent, so I don't have to do this part. I think this is where it gets really slow. I mean, for each node, I want to know. So yeah, we always have the end, right? And then we have a bunch of those, so each one can link to that. All right, each one can link to that. And I don't know. Maybe all we need, the DP, is what is its child instead of what is the actual thing. So the last one will just put itself, right? And then even the children, and then the length. Two things, itself and the length. So the last one will just be push back itself and then length. Length will be 1. And we do the same thing. I go through, Okay, I'm gonna do a slight change and call it solution 2. Yeah, because this is slow. 30 milliseconds, 10%. 30 milliseconds. Do not forget me. Do not forget my name. 24601. So instead of doing this, I am going to put yourself and then do 1. But hopefully better performance. Next child. Next child of the longest path size. Okay. Max child size, max child. But this, if it's empty, haven't visited before, we visit it. Once we visit it, we just do this 1 is larger than. This shall equal to 1. And max child equals max initialization equals a child. Right? Blah 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 blah. We go through this. If max child equals 0, we don't do this. We just update. Max child dp max child 1 plus 1 because I add myself. And here we'll say for dp I need to see which one has the longest. Yeah, max root. Okay. So max root and max size. What do you say? P1 is larger than max size. Max size equal to P1. Max root equal to P0. Okay. Then we can have this res. Now what do? We have the max root and we say node. Now we can say node. Call it node. While dp node zero is not equal to node. Press the pushback node. Node equal to dp node 0. Now we return res. Alright, so this is yeah, it's the same solution, but Hopefully with better implementation. DP node dot empty. DP node is not empty. Right, if it's not empty, and so if it's empty, then that's the end. Will always be begun, will always see, will always be, truly will be the way, will always be, everything to me, everything to me. I don't understand why this one would be wrong. I don't know. Need to debug. Wait, hold on. I think it's 1, 2, 3. What? All right, so what do we have? Let's take a look at a graph. 0 to 1, 0 to 2. That is correct. Path. Path? Huh. We don't need path. Okay, I'll delete it. Nothing on DP. Okay. So it's F2? Yes. What is step in? Shoot. Oh, F2 is step in. Okay, what is index? Index is 0. DP index, I changed to 2. It's 1, 1. Yes. Yes. What's child? Child is 1. Yes. So 1 is also size 2. Yes. So DP child is 1. 1 is larger than current size, yes. Max is 1. Max child is 1. Good. Now we do 2. Child now is 2. Alright, child is 2. Do this. 2 shall be 3, 1. Yes. If it's larger than no, then we're done. Max child larger than or equal to 0. So DPI index, so DP 0 become 1, 2. Correct. Get out. Try next one. It's not empty. Not empty. Okay, down. Node, max size, P of DP. Oh, wait, hold on a second. That should be fine. P1. What's P? P is size 2. Yeah, P1 is 2. Right, larger than max size, yes. So max size equal to 2. Node, what the hell is node? Ah, yeah, that's node. Node is P0. Oh, node is P0. I think I know why. I think I know. It's because this node should not be P0. It should be I. It shall be I. So now node become 1, which is wrong. Right now node is 1. Oh, and also, oh my god, there's so many wrong. There's so many wrong. Okay, yeah, I know why. The problem is here. This is wrong. be dp I perfect. Okay. It's not empty and I see. Don't put nums here. We just do indices. Don't have to be fancy or cute. Okay? Don't be fancy, don't be cute. We simply just do index. Index. Don't do this. You see, we do an index. Max child is index. Everything is index. It's index based. Alright, it's all index. Node, it's index. This is true, right? And then I push back. Here I can do nums node. Alright. Try this one. Ah. Oh, we're just missing the last one. Alright, so I just need to figure out. Oh, we don't need to figure out. No, we do not. Because I have this node on the outside, and I'm keeping, node going, right? Which means I need to jump out, but rest I'll push back. Just put the last one in, because the last node is not in. You just put the last node in and everything is fine. Fine and dandy. Huh. That was not much improvement though. Thought we're gonna see a lot of improvement. I don't know. It just didn't come out how I would hope it to be, but yeah, that's about it. No editorial. Size of the largest divisible sub starting from nums I. Post records the next value in the path of the largest divisible. Yeah, so it's the same idea, but we have 2, right? We have 2 instead of I put 2 in 1. That could explain a little bit difference, but other than that, oh, this also doesn't build a graph. It's simply every single time it just start again. Yeah, I can see that. Yep. Yep. So that's the same idea. Do while. You see that? You can do while. Alright, that'll be it. I mean, it's essentially the same thing, right? Okay, I'll see you guys tomorrow. Adios.